Okay. Try. Yeah, it works. Okay, so thank you everyone for coming. My name is Emanuele Papa, and today we will speak about how Kotlin Multiplatform can be used in iOS and Android apps, and what issues you will face doing this, and how we can work around them. Let me briefly introduce myself. I'm an Android developer. I currently work at Zest1, a company in Chiasso, in Switzerland. And recently we started using Kotlin Multiplatform in our projects. And this is why this talk came up, to show you what are the current issues and how you can work around them. If you want to know more about me, you can read my blog at manuelepapa.dev. But now let's speak about Kotlin Multiplatform. So what is Kotlin Multiplatform? It's an SDK provided by JetBrains to help us build Android and iOS applications using just one language. And its objective is to help us combine the benefits of cross-platform development and native development just using one single language. So how does it work? We need to understand it a little bit before seeing the next slides, if they are working. But we can. What's wrong? Okay, maybe they resume. Okay, so when you create a Kotlin multi-platform project, what happens is that you will have a shared module. That is where you are going to write all the shared Kotlin code. Then you get an Android application, and also you get an iOS project that is your iOS application. So this works because on Android, you can just use the shared code like another third-party library. So it's just something that you're used to do. While on iOS, the shared code is compiled into an XC framework. So like if you are writing an iOS library, and this can be imported into the iOS project. Okay, doesn't work. So after being saying that, the expectations are that you can just learn some Swift UI probably, and you can become an iOS developer. Or maybe you can become an Android developer if you want to learn some Kotlin. Obviously, this is not the reality, because you first need to learn how iOS and Android operating system work, because they are kind of different between them. And also because right now, not everything works out of the box on Kotlin multiplatform. And some of these issues arise because the Kotlin shared code is first converted into Objective-C. And then when you use this code into iOS, you're going to use it with Swift. As you can imagine, since Objective-C is an old language, some of the features we have in Kotlin and in Swift are not supported. The optimal solution will be for JetBrains to drop the use of Objective-C and just convert Kotlin directly into Swift. Unfortunately, this is a very big task. It will take a lot of time. And so in the meanwhile, what we can do is write the shared code in a slightly different way than we are used to do if we just need to write an Android application. And this is to help iOS developers to want to use Kotlin multiplatform, because otherwise some of them don't want to use it because it's something that they're not used to do. So now we are going to see some example of what works and what doesn't, and how we can work around them. I do this showing you some examples, and I start with something that actually works as we expect. Thank you. Imagine to have this function, get random int, that just returns you a random number between 0 and 10. This is in the shared code. So when you want to use this function on Android, you can just call it like a normal function, and you can assign the value to a variable, and you can do whatever you want with this variable. When we do the same on iOS, in the same way we can call this function. Here you can see that there is also random number generator KT, and this is created by Kotlin Multiplatform when the code is compiled, because get random int is a top level function, and so this is gonna be created inside a class that is created automatically by the compiler. Also, one thing you might notice is that here the type is not anymore int, but is int32, which is the primitive type for ints on Swift. And this is done automatically by the Kotlin Multiplatform compiler. As you can expect, this works correctly, and so you can just use this code. Now I want to make this example a little bit more complicated, and I introduce sealed classes. This sealed class that I call KMM int result, it's to model a scenario where our function can success returning our value, but can also fail because for some reason it throws an exception. So in the success scenario, we return the value. In the error scenario, we return a throwable. We so modify our function like this. And for the sake of the example, this function randomly returns the correct value and randomly throws an exception. When we use this function on Android, as you can imagine, we can just use the when statement. And here, for example, we can convert our int into a success message, or our exception into an error message that we want to show to the user. Doing the same on iOS is quite straightforward. You use the switch statement. You add the two cases, error and success. But as you can see, here we also needed to add the default case. And actually, this default case will never be called, because we just have error and success. We don't have any other cases. But the Swift compiler is not able to read the hierarchy of the sealed classes. And so it doesn't understand that we already provided both error and success, and we need to provide this. This code anyway works, but is not the best code you can write, because iOS developers can get annoyed. But there is no solution, at least for this. Now let's make our example even more complicated, because you don't want to create a result class for each type that you want to return from a function. So we make this class generic. So it's just like before, but now it can hold int, but can also whatever type we want. We also need to change our function. So it's just like the same that we have just seen before, just using this other sealed class. And when we use this on Android, is exactly the same code, just different imports. Nothing changes. Now it's where the problem arises, when we want to use this function on Android. As you can see, there is still the default case that we still need to write, but we also need to declare our type, our variable, like KMM result of Kotlin int, and not of int32. This happens because all the primitive types in Swift are structs and not classes. And structs are kind of special classes, let's say, derived from C++, that cannot be used to create generics. So in the standard library of the Kotlin Multiplatform SDK, there are these classes, Kotlin int, Kotlin strings, and whatever for all the primitive types that can be used to create generics when we are dealing with primitive types. But the issue here is that the error case does not even compile at all, because here the compiler is not able to understand that KMM error result is a subclass of KMM result. Let me show you in details what I want to show you. And this happens because here on the left, it's the code that we have just used, while on the right is the code you should write to make this switch to work. And sorry, we need to add also to the error case the generic type. And doing this, the inheritance will work, and Swift is able to understand that also the error case is a subclass of KMM result. This is not the best thing you can do, because actually here we are not using value in the error scenario, because we are just returning the exception. But this makes the code work. If we want to improve this, there is another thing we can do. What we can do is create an enum in Swift to model this scenario. So we create this enum with error and success. And for those of you who don't know, enum in Swift are not like enum in Kotlin, but are more kind of seed classes. So this can be instantiated, and you can associate a value to them. And we also need to create this function that will help us converting our KMM result into a Swift result. So adding these two type checkings, we can cast the KMM result instance to a Swift result. And then you can just use the Swift result in Swift UI or in whatever other code you write in Swift, avoiding to write the default case, because now the compiler is able to understand that just success or error are the two cases for this enum. You might imagine that this can become cumbersome, because for each seed class you have in the shared code, you need to write the enum and the code to convert it. So it will be time consuming. And what you can do is actually to use this library provided by IceRock. Since this thing can be automated, they created a Gradle plugin that you can apply to the shared code. And when the code is compiled, for each seed class you defined in your shared code, there is a new enum that will be generated that you can use on iOS. To show you an example, this is the code that will be generated for our KMM result class in the shared code. So it creates a new enum, KMM result KS, that stands for K-Swift, with two cases. And in the initialization of this object, it does the conversion that we manually did in our conversion function. Now, let's change topic. Now I want to show you what doesn't work when you use inline classes. So inline classes are very useful when you have a function like this, format first and last name, that it takes two parameters that are both of the same type. So at compile time, the compiler is not able to help you understanding if you are making a mistake. So you can pass Emanuele Papa, but you can also pass Papa Emanuele. And when they are returned back to you, in the second case, you pass the wrong arguments. So to avoid doing this, you can introduce two value classes, first name and last name, that both wraps a string type. And so when you write your code, the Kotlin compiler is able to help you understand that you need to pass the correct parameters. Now let's see what happens when you want to call this function on iOS. There is no more types for our arguments. And this is because inline classes are just removed at compile time, so they are not anymore available in the code that is created. And so from iOS, when you call this function, you can pass whatever argument you want or whatever type. Obviously, this is not usable because from iOS you don't know what you need to provide to this function. And there is no official suggestion for this because you not only lost the inline class type, but you also lost the type that they were wrapping. So you don't even know that first name and last name are strings. What I suggest you to do, that is just for iOS, is to create the same first name and last name value classes, but not as value classes, but as data classes. And you can create also another method that wraps the original one. And so you can use this on iOS without having issues providing arguments. This is not the best thing you can do. Maybe it introduces some overhead because you have two new classes, new function. But at least iOS developers know what arguments they need to provide to your function. Now, let's speak about a topic which is very hot nowadays, that are coroutines. As you know, coroutines are very helpful when you need to do something in the background. But of course, not of these exist in Objective-C because Objective-C is an old language and doesn't support coroutines or kind of similar. So imagine to still have this method that still formats your name, your first name and last name, but now this is a suspending function. So we add the suspend keyword, and we also add a delay on 1 second just to simulate the background work. When you call this on Android, as you know, you can just launch the coroutine, for example, in a view module scope. You can get the value from the function, and then you can show it to the user or do whatever you want. Now I'm going to show you what happens when you call this function on iOS. As you see, now we don't get the value returned back directly from the function, but we get the result in a callback that we need to provide to our method. So in this callback, we can get back the result, which is formatted name, or we can also get back the error, which is the exception that can be thrown by this function. This is a big problem because doing this, we also lose nullability information on our types because both formatted name and errors must be null for this to work. Because when you have the value, you don't have the error and vice versa. Also, you need to remember that if you want to update the UI, you need to manually change the thread to the main thread because otherwise your app will crash. And this is something that we were used to do on Android years ago, while now we don't do it anymore because the scopes and coroutines do it automatically for us. Like for us and for iOS developers, there is a solution for this, which is another third-party library, KMP native coroutines. That is another Gradle plugin that you can apply to the shared code. And for each function that is suspending, and also actually for each function that returns a flow, it will create another function that will be made available just to the iOS code. And with some functions of utilities provided by this library, it can help you use these coroutines with RX Swift or Combine, which is a kind of RX Swift for iOS. So here in the example, using create publisher, we create a combined publisher that then we can subscribe to, and we can also receive its value in a kind of RX Java if you are similar, if you are used to use it. Just to complete this chapter on coroutines, you need to know that there are still a lot of issues switching threads when coroutines are run on an iOS app. And JetBrains just released a new memory management model that helps you not doing a lot of things that you needed to do in the shared code manually. For example, you needed to freeze all the instance of items that you wanted to share between threads, because otherwise it doesn't understand that the item is not mutable. And so I suggest you to use this new memory management model that is already available in the latest version of Coroutines. But if you are using, I think, 1.6.20, you can enable it by adding this line in your Gradle properties. Anyway, this is a very big topic, and we can't cover it in full now, because I think it will take hours and not minutes. So if you want to know more, you can go to the JetBrains GitHub. There is a very cool README where they explain everything they are doing. Now I want to also speak about the result class. The result class is something you might get used to use when you're writing Kotlin code that models success and error scenario, like we were doing some slides before. So let's still use this function that returns a number. When we use on Android, you can just call the fold method, provide on success and on failure lambdas, and you can handle the exception or the value. For iOS guys, when they call this function, they just got any type. And this happens also because as the same type, in the same way, the result class is also inlined. So also this class is removed. So my suggestion is to use the result class only in the shared code that is not put as an API to the app layer. And when you want to create an API that is shown to the app layer, convert the result class into a result class that you made your own. Like in the previous example, we made the KMM result. That is something that is just a data class that is not inlined, because otherwise it can't be used. Unfortunately, another thing that doesn't work is default parameters. Default parameters is something that I think we are very used right now by Kotlin developers. And all of this doesn't exist on in iOS in Objective-C. So when the function with default parameters is called on iOS, you need to provide again all the default parameters. And unfortunately, there is no official solution for this, but I didn't also find a third-party library to solve this. I think that this can be solved by code generation, maybe generating all the possible combinations. But anyway, it won't be. I didn't find anything till today that fixes this. Now, another different topic, which is exception handling. Exception handling is completely different from Kotlin and Swift, even if Kotlin and Swift are very similar, and this is something that we hear every day. Exception handling is completely different, because in Kotlin we only have unchecked exceptions, while in Swift we only have checked exceptions. So what happens? What happens when an exception is thrown in the shared code running on iOS? Well, your app will just crash. And this is because exception thrown in the shared code are treated like runtime exceptions. And so iOS doesn't handle them, and the app will crash. If you want this exception to be propagated to the iOS layer so you can handle them, you need to annotate the function in the shared code with @throws. So you kind of make your exception a checked exception, like we did in Java years ago. I don't think this is the best approach because we are not used anymore to declare exceptions. And also if we remember to do it, maybe with a linter or whatever, in the end, what we get is that we have two different ways of handling exceptions between Android and iOS. And this is not what we want, because we want to write code that is much more similar between the two platforms. So what I suggest is to use a result-like class, catch your exceptions at the lowest layer possible, and just return this result class to the up layer, so you can then handle it with a switch or a when. Now, let's speak about third-party libraries. Third-party libraries are something that we use every day, and so we also want to use them in Kotlin Multiplatform. For this, there are different scenarios. When the library is a pure Kotlin library, you can just import it in the shared code because it will just work most of the times. If this library is another Kotlin Multiplatform library, you can use it because the author of the library made it able to work on Android and iOS, and so you can use it. The issues arise when you are going to use an Android native library and an iOS native library. The first time I was doing this, I was expecting that I could just create an interface in the shared code, and then I could use the Android library and the iOS library to make the real work under the hood. Unfortunately, this doesn't work if still on iOS. The problem is always there. If the iOS library is written in Swift. And this is still related to the fact that we need to use Objective-C. And since most of the libraries now are just written in Swift and not in Objective-C, you can imagine that most of the libraries won't work. So here we don't have other choice to actually drop Kotlin Multiplatform and write this feature natively for Android and for iOS. We actually didn't want to drop Kotlin Multiplatform at all, so we came up with a solution inspired by clean architecture. What we did is we created an interface in the shared code, and we also created its implementation. This implementation is where we run the business logic, but the business logic here is just a delegation to the implementation that is then done in the native code for Android and for iOS. So here the classes, the interfaces in purple just acts like your domain layer, and the Android and iOS implementation acts like your data layer. So here you just get the data, you use the third-party library, but in the shared code you manage how this data must be taken from an API or I don't know, something else. You should also you should do anyway 2 implementations, so there must be issues in doing something different. But at the moment there is no other solution than this. You still get that the business logic can be shared in the shared interface. And for example, if you want to add a layer of caching, you can do it just once instead of doing it twice for Android and iOS. Still speaking about third-party libraries, if you are going to create a library for your company or for the community, you should know that there is this plugin Swift package from G.org that lets you publish your library as a Swift package instead of Cocoa pods. And so your iOS developer colleagues will be much happier to use it because they don't have to use pods anymore. Now we are just come to near the end of the talk. So let me give you a few more tips. Let's start from iOS this time. And I want to tell you that if you are an iOS developer, you love Xcode. And probably you don't love Android Studio. This is at least what in my experience was happening. So the guys at TouchLab that are very well involved in Kotlin Multiplatform. So I suggest you to follow their GitHub. Created a plugin for Xcode to make Xcode being able to debug the shared Kotlin code directly from Xcode. So assuming that iOS developers are not writing the shared code from Android Studio, they can just use Xcode, write their Swift UI, and if there is something that doesn't look good, they can also debug the shared code written in Kotlin. At the same time, I don't think there is anyone in this room that loves Xcode. And so, lucky for us, JetBrains created AppCode, which is an IDE very similar to Android Studio or IntelliJ, that can make most of the things, if not all the things that are done by Xcode. So if you want to mess with Swift UI, I really suggest you to use AppCode because it makes your life very easy rather than using Xcode. Now, we have reached the end of the talk. We have seen that there are still a lot of issues using Kotlin Multiplatform. But we also have seen that you can work around them most of the time. So these issues are not blocking at all. And we also need to remember that Kotlin Multiplatform is still in its alpha stage. And it already does a lot of the things that we usually do. And actually, these issues are just at compile time. Because once the code is compiled, you can deploy your app and, let's say, be sure 99% that everything will work. So my message would be for you to use Kotlin Multiplatform if you haven't used it, because you won't get disappointed. You just need to make iOS developers be aware that Kotlin Multiplatform is a thing that it's spreading, and they will be happy actually because they need to write less code if you are taking the ownership of writing the shared code. And the more people use Kotlin Multiplatform, the more issues will be discovered, because issues can happen maybe just to one developer on 100. And so the more people use it, the more issues will be discovered, and the more issues will be fixed by us, by someone else, by JetBrains, but at least we can raise issues. And so eventually we can get a language, a technology that will make us able to write Android and iOS apps just with one language, which is Kotlin. And so maybe one day we will make this dream of writing Android and iOS apps with just one language to become true. Thank you. Thanks for your attention.
Thank you very much. That's an